Hey guys, now we are going to solve question number 4. Let's see what the question says. A long solenoid of radius r carries a time t dependent current it equal to I naught t into 1 minus t. A ring of radius 2r is placed coaxially near its middle. During the time instant, that is t between 0 to 1, the induced current IR and the induced EMF VR in the ring changes as. Now this graph is going to be made. So according to the question, the graph will be made in such a way that it would be starting from fourth quadrant. E initial would be negative and it would be going towards the E final, comma 1 coordinate in the first quadrant. So the value would be going from negative to positive. Now let's solve it. Field due to solenoid near the middle is known to be mu naught Ni, and flux is defined as B into A, where A is pi capital R square. So just simply put the value of A in this, and we are going to put the value of B, that is given as mu naught n I naught into t into 1 minus t into pi r square. And also according to Ben's law, E is defined as by dt, and we are simply going to put the value of flux in this, and this is our value of flux. We are simply going to put here, and we reach the position in this equation where E is equal to minus d upon dt mu naught n I naught into t 1 minus t pi r square upon dt. So the differentiation is going to be in terms of dt because the denominator terms is dt. So just simply take out the constants out of these equations, and like we did in this equation, the constants are taken out and the differentiation is going to be applied on t into 1 minus t, and t into 1 minus t is our ft. Let's take it as ft, and it comes out to be t minus t square. And if we calculate f dash t, that is ft derivative with respect to dt comes out to be, this is t, sorry, it comes out to be 1 minus 2t, and this ft is written over here. This is our ft and this is our f dash t substituted here. Now current will change its direction when EMF will be 0. So just put the value of f dash t equal to 0. Now from this equation we can see that 2t equal to 1 and t comes out to be half second or 0.5 second, and C would be our correct answer.